But Neville is Chief Technical Officer at Ricardo and is going to speak for 10 minutes or so on future technologies. Thank you.
Thanks, Nick, and thanks, Richard, for saying most of what I was going to say. But we admire your enthusiasm and also your leadership. I think it's been a very interesting period over the past 4 or 5 years as the Auto Council has developed. I'm going to talk for a short while about UK low-carbon vehicle technology developments. I'm an engineer. That is someone who was good at maths but didn't have the personality to be an accountant. So I will involve some technical information, and I'll make apologies for that straight away. My company, Ricardo, is a leading UK-based global provider of product innovation, engineering solutions, clean technology and strategic consulting in the US, in Europe and in Asia. And what I'm trying to do is provide some context to where I think the UK is at the moment. I deal with governments in the US and in China and in Brussels quite a lot. And I've looked at what are the key USPs that the UK has. We tried to get the UK to work together for a number of years. I've been in automotive for 30 years now. And I think this is the first initiative that has really proved to work. We've managed to get a level of coordination that perhaps we haven't seen before. We have the Office for Low Emission Vehicles, a cross-department group that gets the government departments to work together. We have the Technology Strategy Board we've heard about, which is very well coordinated with industry. The Energy Technologies Institute, which primarily looks at energy, but also looks at heavy-duty vehicles. And the Engineering Physical Sciences Research Council, the group that funds university research. All of those groups are members of the Automotive Council. And that's why we achieve the level of coordination we have. And it's a great initiative that I don't see anywhere else outside the UK. Having said that, we have some big challenges. The theme of this event is quite consistent here. We see 3 core societal challenges for automotive. There are future issues surrounding the mobility factors, future generations, attitudes to car ownership. Who's going to buy vehicles in the future? I have a 20-year-old son who has no interest in buying a car. He wants a different form of mobility, when he wants it and how he wants it. We have policy disruptors, localized regulations could be a disaster. We need a lack of international standards could take us the same way. But we have these 3 main issues: safety and security. We must make vehicles safer and roads safer. We have sustainable manufacture. We mustn't have an environmental impact. And then we have the whole energy issue and greenhouse gases. And there are a number of things we can do to address those. I'm going to focus a bit more on the greenhouse gases and energy efficiency, but the others are just as important. Reducing the use of fresh water, material leasing. We've already heard about rare earth materials and the issues we're going to have with that. Hopefully, nearly all of you will have seen this roadmap. If you haven't, please let me know, because you're the one person we haven't spoken to yet. The industry in the UK got together to put together a consensus view of where we would see technology roll out over the long term. The most important parts, perhaps, in that are the 2 grey boxes at the bottom, the improvements in our current technology, looking at renewable fuels, and also vehicle weight and drag reduction. Those are continuous pressures that we will work on over the coming years. We'll see a move into micro, mild, full hybrid systems and into plug-in hybrid systems when we have batteries that are cost-effective for the mass market. Before that time, we'll have niche products and demonstrators. Eventually, we hope to get to fuel cell vehicles, and my colleague James is going to talk about our fuel cell developments later. But that's clearly a long-term goal on where we want to get to. We've also produced a roadmap for heavy-duty vehicles. Now, this is a bit more complicated because the technology tends to be application-specific. We've got 2 key drivers in that area. First is to improve air quality, and the second is to reduce greenhouse gas emissions. And we've got some work to do to get to virtually 0 or negligible air impact in the first stages before we can probably address the CO2 one. For heavy-duty vehicles, our choices are a little limited. We really need to focus on IC engine efficiency improvements, using more of the waste heat that we get from engines. All that energy we put in from the fuel, we only use about 30 or 40% of it at best. The rest we just throw away into the atmosphere. We need to use more of that. We've also got the intelligent vehicles and logistics, operational efficiency, certain amount on aerodynamics. For medium-duty vehicles, looking more like passenger cars, looking at hybrids, looking at plug-ins perhaps, and some fuel cell vehicles. And for light-duty commercial vehicles, pretty similar to passenger car. But this is, again, a consensus view from the industry, how we see technology roll out for commercial and off-highway vehicles. We still need this breakthrough in energy storage, though, if we're going to move away from the internal combustion engine. It's going to be a big challenge. I'll come back to the 5 key areas that Richard spoke about earlier. These are the key areas which we think we need to work on to deliver those roadmaps. First one, the internal combustion engine. For my sins, I'm leading that group. We see it as the most effective short-term route to CO2 reduction. We have all the necessary elements for the supply chain. I'm really focusing on how do we make engines work better with electric machines. The electric machines and power electronics group really focused on the supply chain development, as Richard described. In energy storage and energy management, we have a lot of UK technology in advanced battery chemistry, flywheel technology. The UK pretty much leads capacitors. Initial focus is on the prototype material and scale pilot line facilities for lithium-ion batteries. Lightweight vehicle and powertrain structures, again, we have a good UK lead. There are also further opportunities to benefit from what's going on in UK aerospace. And in intelligent mobility, we all see a future route to make the vehicles more intelligent. They say the least intelligent part of a vehicle is the driver, or the nut that connects the steering wheel to the road. But there is a link to support to the UK transport systems catapult, which was described earlier. There's a lot of things we can do with intelligence. Worth remembering, it's the off-road sector that are probably leading in this technology. And there's a lot that the on-road groups can learn. So just say a few words about the internal combustion engine, since I'm leading that group. As we said before, improved internal combustion engines will deliver the majority of fuel consumption and CO2 reductions over the next 10 to 20 years. Downsizing and boosting is probably the most cost-effective strategy, but particularly in heavy duty, whether it's on or off-road, we need low-carbon, sustainable fuels. That's something else we need to work on. We've also come up with a technology focus for both light-duty and heavy-duty vehicles. I've given you the list there. Some of the important things there: electrification, integration with e-machines, waste heat recovery, and combustion engines for range extended or plug-in vehicles. A few words again about UK positioning on combustion engines. We spend around 50 million in ICE research across industry and academia collaborations. We have some internationally leading university research teams on turbomachinery, on advanced combustion. In terms of product development and manufacture, we've just done a survey of how many engines we make in the UK across all sectors, not just automotive, and it comes to around 2.75 million. It's a lot of engines. A vast majority of those are exported. They're high-efficiency downsize, leading construction and off-highway engines. We have JCB, Caterpillar, Perkins in the UK. It's about 500,000 engines a year in the off-highway sector alone. And world-beating high-performance engines. A lot of the Formula One engines are made in the UK. And we have the internationally leading contract R&D organisations. They provide an influx of new ideas and innovations, reducing the investment costs for OEMs, delivers projects faster, and flexible capability. So some great capability there. I'll just finish off with some of Ricardo innovations that we're bringing to market. All of the things I'll talk about are supported by the Technology Strategy Board. First one we see as this first step into how do we integrate engines and electric machines more efficiently. A relatively conventional Ford Focus down to 95 grams per kilometre using what we call intelligent electrification. It's not really hybrid, It's a cost-effective hybrid. It's a great way of getting to good fuel economy. Next one here, flywheels. We've been looking at high-speed flywheels. High-speed flywheels have emerged from Formula One. And we found a way of connecting these via a magnetic transmission, a very high-speed magnetic transmission that is more efficient than a set of gears. So you can operate the flywheel in a vacuum. Looks very, very interesting for the future. And finally, maybe even more innovative, the next generation split-cycle recuperated internal combustion engine offers over 60% thermal efficiency. This is really where we need to go for the heavy-duty applications. Thank you very much.